Let's begin the webinar. Good afternoon, everyone. I'm Abhay from EDS Technologies, and I welcome all of you to our webinar today on powering the future, dive into EV motor and battery simulation with SIMULIA. Before I start, before I'd like Sanjeev to begin with the webinar, I would like to give a short introduction about our company, EDS Technologies. EDS Technologies was incorporated in 1994 to focus on providing PLM solutions, implementation, and support. We are the largest technology solutions provider in India and also the platinum partner to Dassault Systems. We have served more than 2,000 customers across India and operate in 10 locations, with our headquarters being at Bangalore. We also have various strategic partnerships with world leaders like EOS for additive manufacturing, Human Solutions for ergonomic solutions, Technia for ensuring product data quality. For military simulation and training needs of aerospace and defense industry, we have partnered with MAC for visual simulation solutions. With respect to EDA solutions, we closely work with Synopsys, and for GAS, we have a partnership with ESRI. We have a dedicated sales, support, marketing, and customer satisfaction teams to address customers' PLM business and support requirements. Coming to the EV industry in particular, we are engaged with multiple EV manufacturers in India. In terms of solutions, we support them for battery engineering, body structure engineering, charging infrastructure, electric powertrain, interior and exterior trims, and electrical wiring harness. In today's webinar, we are joined by our speaker, Mr. Sanjeev. Mr. Sanjeev carries an industry experience of more than 3 years in the field of 3D experience, SIMULIA, involving technical support and training. At EDS Technologies, he handles all the pre-sales and post-sales activities in the southern region for the SIMULIA brand. Before handing it over to Sanjeev, I'd like to inform the audience that we shall be taking up the Q&A after the delivery of the webinar. We shall also be accepting queries through the question box, which shall also be addressed post the webinar. Hope you have an exciting and knowledgeable session. Over to you, Sanjeev.
Yeah, thank you, Abhay. Thank you for the introduction. So good afternoon, all the participants who have joined. So this webinar, so we will be taking you through the vehicle electrification. So what are the factors involved in the vehicle electrification? So what are the challenges current industry are facing? So when it comes to vehicle electrification, the really battery module pack so has its own challenges. So we will be presenting our solution. So on back the module, what are the solutions that we can provide as a to the customers to enhance their battery performance. So along with the battery, so major other important component in the electric vehicle is like the powertrain. So when it comes to full vehicle integration, the motor plays a critical component. So when it comes to motor, you need to perform various validations. So either maybe a strength in the structural stiffness. So it can be an
Sanjeev, sorry
yeah,
to disturb.
yeah, yeah.
We are hearing little echo. If you can keep your mic little bit far away, it will be okay.
Yeah, just to let you know, like, how about this? Is the voice clear now? Or
Yeah,
can
now it's
I
fine. Yeah,
still
now
fine?
it's fine. Yes, yes. Please
Okay,
go.
okay. Thank you, thank you. So yeah, so as I was saying, motor is one of the critical component. So we will be seeing so how we can evaluate our motor performances in terms of structural, along with the in terms of fluid dynamics, along with the electromagnetic solutions as well with the Opera. So we will be seeing in depth so how we can various parameters in Simulia and then optimize the results in terms of structural CFD along with the EM solutions, which is provided by the Opera. So Opera is one of the leading software in the low frequency domain. So you can solve different EM solutions. You can solve different EM problems with the Opera and then obtain the solutions. So in this webinar completely, we will be looking into this particular topics in detail. So I will be presenting for this agenda in this webinar. So the part of As an end of the webinar, we will be showcasing our customer references in terms of global partners who we are supporting, so who are all using these particular solutions as a global level. Along with there will be a session for Q&A. So if you have any other questions, like you can just have a discussion. We can have an interaction at the end of the session. So I hope so. The agenda is clear to all the attendees. So we will start from the main challenges of the vehicle electrification. Yeah. So when it comes to the vehicle electrification, you can see so there are a lot of challenges. So you can see right from the high initial cost of batteries, so and then the safety aspects, the regulation which is passed by the governments, the varying regulations. So all the comfort parameters and the battery life of the battery. So and then the long recharge time. So there are various aspects which is involved in the battery level. So when it comes to the solution that we provide, so it is an optimized solution to overcome all these multiple challenges which is faced by the EV industries in this market. So so how we can increase our safety aspects of our battery. So in terms of thermal, as you can see in this particular example, so how the thermal efficiency has been optimized. So how the temperature is being gradually reduced. So by performing different iterations in your designs in terms of both the design and the simulation. So how SIMULIA helps in obtaining these optimized designs. So and then thereby eradicating all these particular challenges in your industry today industry challenges. Okay, so we'll be seeing from the battery module, so how we can eradicate these challenges, and majorly one of the other main concern when it comes to EV industries is the time-consuming process. So you can see here, so whenever you develop a cell prototype, so until it goes to the testing to the laboratory, so it consists of certain weeks. So you have to wait for the proper design production. So then it is being tested. So once it is tested, the testing, it comprises of various testing. So both the mechanical combination of multiphysics, both the mechanical and electrical, thermomechanical. So all these kind of complete analysis has been to being carried out with the right from the cell level itself. When you compare this as a whole together, it assumes let us assume like it is a 35 plus weeks. It is taken to assess a single cell level. So this is kind of particular challenges which has been faced by the EV emerging EV industries in the recent market. So this is one of the a particular flow cycle where the current industry are being following to test their prototypes physically. So let us see how our solution helps in reducing these kind of time consuming processes. So within the single prototype, how you can perform multiple level of testings. In case of just by having a single FEA model, you can perform different various testing scenarios, thereby reducing your number of prototypes and cost. So let us go in the deep, how we can simulate these kind of cases and thereby reducing the time. Yeah. Now let me begin from the cell level. So you can see this when you construct this cell, right from starting the battery cell design, you can look into various aspects of your cell. So it can be either of a thermal aspect, it can be either in the safety aspect. If you see, you can perform these kind of drops or foreign object impact test. So also when it comes to strength, stiffness, and durability.
Sanjeev, sorry, uh,
Yeah.
there's some disturbance. Can you remove the headphone and then speak?
Yeah. Yeah. How about now? Is it
Yeah,
clear?
now it's fine.
Yeah, thank you, Abhay. Thank you for turning. So yeah, as we were saying, when it comes to the particular cell level, like you can see, so right from the cell level, we can analyze our part in various aspects. So it may be a thermal management or a safety. When it comes to safety factor, it can be a drop test or a foreign object penetration test. So when it comes to strength, stiffness, and durability, so we have different kind of loading scenarios to test from the cell level. So all these complete portfolio can be analyzed with the help of a single FEA. So we can see certain cases how this platform SIMULIA, how the SIMULIA helps in gathering and performing all these various kind of load scenarios. Okay, so the major important thing here is like with the help of our solution, like we can assure you like we can maintain the foundational standards. Let us say like whenever the EV market is being considered, the IEC standard is one of the major standard, foundational standard. So you can easily maintain your particular standards, either it can be a 60068 or 62660 in terms of mechanical testing, temperature testing. So all these kind of different testings according to the IEC standards is being maintained. So not only for your particular battery packs, whenever it comes to the full vehicle, so there are a lot of components involved in the electric vehicle. So when it comes to these kind of assurance, like you can just ensure this particular solutions to ensure your particular foundation standards are well maintained. So these are some of the examples which are showcased here, like for a full vehicle, if you can see here, right from the charging topology, the communication unit, all the connector units, and the safety and security units. So all these standards apart from IEC, like you can see like ISO standards, so all the SAE standards, all different standards has been maintained by our solution. So this is one of major criteria, like wherein you can enhance your product's quality and your organization growth in a much bigger way. Yeah, so you can see here like one of the example like how this exact physical prototype testing has been replicated in the SIMULIA solutions. So you can see like how the fixtures has been defined, how we are defining the clampings of the particular test type. So how we are applying the load for the loading plunger. So how the cells has been particularly deformed. So you can just in a single unified environment, you can just define all your boundary conditions necessary to the particular loading scenarios. So along with the help of general contact algorithm within Abacus, you can just uh, easily generate the contact domains. So whatsoever, how many paths are in the assembly, you can within a single go, you can just you can just build your contact domains and then give your interaction properties. So with the help of these kind of multiple user-friendly applications along with the user assistance, so this makes the user to simulate your particular prototypes in a much aggressive, faster manner rather than comparing to the traditional ways. So once you evaluate your products, you can just completely post-process your results in terms of all the external surfaces, and also you can take your cross-sectional views, and then you can completely view all the inner plots, how the interior of your cells has been damaged. So all these kind of different various contour plots can be taken, all the one versus plot, how the displacement is been happening. So within throughout the depth, you can just analyze how the cell is being deformed due to this particular impact load or the penetration load. So all these kind of standard three-point bending test, all these kind of different testings which is provided for the single cell level can be easily performed within the single FEA model. So with this FEA model, you can also add a lot of scenarios, and then you can build n number of structural cases and then change your loading conditions, and then thereby evaluate your products completely. So thereby reducing your number of prototypes. So the other scenario you can see here, like so when it comes to the safety scenario, the as I mentioned before, this drop scenario is one of the major concern. Like so, whenever it has been mishandled by the during the operations period, like you can just simulate these kind of effects, which is dynamically, which is explicit in nature. So you can just use this kind of explicit solvers to perform these kind of drop scenarios. You can just virtually create your build flows. So and then you can assign you a certain height. So how much should be your drop height, and then assign your particular velocity to your paths. So you can just easily assign your boundary conditions for this kind of FEM models and then evaluate your results. So in cases of these kind of misuse or the safety aspects when it is mishandled, so how the object is being performed, how the structural integrity is being maintained in these kind of scenarios. So these kind of things are very much possible within this particular SIMULIA solution. And also when it comes to these kind of explicit where I mentioned, so you can take various energy output plots, thereby comparing how your internal energy is being continuously matching with your kinetic energy. So all these kind of various energy plots ensures you that your product is in particular safety level. So there are various output plots in terms of contour as well as these kind of X-ray plots provide you a major in-depth product performance evaluation in your particular product. So you can see here, like we have taken all these kind of particular uh, uh, the kinetic energy plots, internal energy plots. So how it is the velocity is varying with respect to time, how the energies are shifting with respect to time. So all these kind of in-depth level of analysis can be done right from the cell level of the battery pack. So you can see the various examples on different drop scenario cases, like how your stresses and the displacements are varying with respect to time. So by this, you can just increase your performance of your products even right from the cell level. So thereby, as when you compare it as a whole battery pack, so you will be having your more stable and robust product. Yeah, so these are the various other scenarios you can just test right from the cell level. You can do the axial compression, radial compression, so 3-point bending and the impact test. So these are the few scenarios. Yeah, and this is applicable also to the complete module and pack level. You can see like the same thermal safety and the strength stiffness factors can be evaluated for the module level as well. So I can just quickly go through all these kind of different testings which is performed even in the assembly level. When you see these kind of abuse testings like a crush, drop, shock testing, so all these side penetration test and top penetration tests. So all these scenarios are very much possible, and then you can evaluate your complete product's performance. So how it has been behaving in these kind of situations. Yeah, and also these kind of optimization algorithms provide more value to your products. So thereby you can just increase your, you can shift your initial natural modes of the frequencies, lowest frequencies, thereby increasing the stability of your part with minimized material. So all these kind of the bead optimizations, all these kind of techniques, the optimization algorithm provides more stability to your part. And also with the help of these kind of thermal management solutions, you can completely eradicate these kind of thermal problems. So how the flow pattern is behaving within the battery pack on the module. So how the flow pattern can be changed, how the spacing can be oriented within your individual cells. So either it can be an loosely packed or a tightly packed. So you can see the different configurations, how the flow pattern is varying across the particular internal distribution within the cells. So when it comes to full vehicle integration, so this particular you can see like when it comes to vehicle, you can perform these kind of vehicle dynamics, crash worthiness, and the thermal management. So and then when it comes to the integration part, this electric drive plays a major role in this particular EV industry. So for this electric drive performances, you can just evaluate both the strength, stiffness factors, durability factors, lubrication factors. We will be seeing all the examples in a short while. So how the for your electric drive motor, how you can evaluate your products in terms of strength and stiffness, lubrication performance. So all these electromagnetic performance. So all these kind of things can be all kind of multiphases can be compared and simulated within this particular thing. So you can see different workflow for your motors, like you can have your strength and stiffness workflow, and then these you can add your fluid simulation setups in this particular workflow. So when it comes to strength and stiffness for your motors, like so there are different EV configurations in this market. Like as you can see here, like Tesla is using both the single and dual motors, and also a particular model in Tesla, like Roadster, is using this triple motor.
So when it comes to the four motor like Rivian R1S is particularly using this particular configurations. So in this competitive market, like to configure your EVs based upon your performance, so optimizing this motor is a particularly a major goal in this particular EV industry. So either it can be any kind of configurations, but your the critical part of this configuration is your particular EV motor, where you place it and how you design it. So we will be seeing like how we can increase your EV motors performance in terms of both the structural and the max solutions as well. Yeah. So when it comes to like motor performance in terms of structural, like you can just simulate in different loading scenarios. Like you can provide us either static load or dynamic loading conditions. Then evaluate these kind of how much stresses is building in it within your casing and the stators or the rotors. So all these kind of displacement plots give you an idea like so how it can be mounted and then how it can be eradicated all in these kind of dynamic situations. So all these kind of structural performance have been completely evaluated right from the designing phase itself. So it will be so the CAD integration and the simulation results are integrated in hand. So by evaluating your results during in the design phase, you can simultaneously change your model and then improve your performance right from the design stage. And when you come to this particular motor configurations, like when it comes to structural stiffness integrity, you can see like not only the motor components, all the supporting components for your placement of your motor, all these kind of brackets where you can see here this particular bracket, you can see how it can be optimized using topological optimization within the SIMULIA solutions. You can see like you can increase your when it comes to the motor casing, like you can increase the number of ribs, fins. So all these kind of particular parameters are parametrically optimized, and then the topology optimization also is done with this particular topology algorithms. So you can see here like the initial design of this particular bracket, so how it has been particularly optimized along with this particular ribs, you can see in this casing. So whenever you start with your initial design, so you can see like how your ribs and the initial particular brackets are there. So once you bring in this particular bracket, your topology optimization, you can define your particular fixtures and all the necessary loading conditions. So based on which the constraints you provide, like the software will, based upon the topology algorithm, so you can just create the software automatically eliminates the necessary the masses in the necessary unnecessary area where the stresses are not acting. So these kind of optimization adds more value to your strength and stiffness aspect for your parts. So you can see here right from the initial design how the final design has been optimized by these kind of optimization techniques. So this will be adding much value to your particular parts in terms of weight and also the stiffness. Thereby, you can reduce or save more cost in terms of optimization when it comes to individual parts. So you can see how this particular bracket has been optimized. So then you can replace your particular the old bracket with this current new one, which has been optimized. So you can see, and then you can evaluate the particular stresses, which is still in the same range, but even though you are reducing a much more mass, so then without lacking the structural integrity. You can see here like the original design, how much there's been deflected and how the stresses are being varied throughout this particular component. So and then you can easily compare simultaneously with your old and new designs. So then you can optimize your products. So these kind of optimization adds more value to your particular motor components. Then easily you can review and collaborate within your stakeholders. So you can just add more value to your product's performance. So when it comes to these kind of additional to the strength and stiffness aspects, along with this kind of lubrication performance can also be evaluated for your motors. So when it comes to these kind of, let us consider this particular EV motor. So you can see like how we can improve this kind of thermal efficiency in terms of lubrication. So in this case, like you can see this cross section, like how we have provided our coolant jackets. So you can place your coolant hoses and then you can design your motor. So once you pass the coolant inside these kind of chambers, like you can evaluate the product's performance in terms of temperature, how the uh, thermal dissipancy is being occurred due to this coolant. So let us see an example like you consider this particular EV motor section. So wherein we have a certain number of water jackets, thereby we will be passing in the coolant. So how it has been, the heat has been drastically reduced in place of this particular coolant. So once you perform these kind of analysis, like you will be obtaining like when it compares to the original design, it has 10 casings. When it comes to this particular jackets, let us consider the original design with 10 jackets will be producing of 101 degrees Celsius. You can see like so the various contour plots, so within which how the stator has been particularly the temperature has been spread across this particular stator, and how it has been spread in the casing. So all these kind of various contour plots along with the streamlined pressure plots and the velocity plots, you can have a thorough insight of your product's performance. So along with these kind of plots, you can also have your surface plots like HTC, how your the heat has been carried out throughout the surfaces. All these kind of plots help you in gathering insights ahead of the production stage. Okay, so this is one of the example. Like the one of the most important thing is like you can see here with this particular 10 jackets, you will be producing this kind of certain temperature. So it is hand in hand when I mentioned like whenever you change your design, all these kind of reflection design changes has been instantly captured by the FEM as well. So you can see here like whenever you model this particular stator, this cooling chamber, so where you can see like this initial design has been particularly meshed now. You can see this part is particularly meshed with the tetrahedron mesh. So you can see the part. So now it is completely meshed here. So if you just isolate that part, you can just see how the part has been meshed. So now this with the initial configuration of the design, you have designed and then you have particularly created your FEM geometry. So in case if your designer is particularly changing your design, if in case if he's reducing this number of jackets, so let us say like I'm just controlling this revolutions. If you can see in this feature manager tree, like so this is very well integrated with your design CATIA platform. You can see this CATIA assembly design, so along with our structural SIMULIA roles and then CFD SIMULIA roles. So whenever you change your initial design in terms of these kind of parameters, there are a lot of parameters controlling this particular part. So you can see this whenever I'm just editing this particular revolutions, number of revolutions. So instead of 10, I'm just varying a different uh, level of a jacket. So I'm just entering it as a 5 with this. With respect to this particular parametric change, so your model will be automatically getting regenerated. And then you can see your particular design with the five channels. So once you change your design, so just by a single global update within the software, you can just replicate the same boundary conditions and everything along with the updated mesh. So once you change your design, you just pulling back into your simulation role. So once you go back to your simulation role, just you can just globally update it, and you can see that the still the FEM geometry and then the mesh is still maintained even though the design is changed. So this kind of integration between your CAD geometry and this FEM model so plays a major role in saving more time to reinitiate your pre-processing stages. So you need not remesh it again, you need not define the boundary conditions again. So all these kind of FEM parameters are still maintained even though the design has been changed hand in hand. Just by the single update, you can just maintain this kind of design changes. So along with preserving your pre-processing conditions. So this kind of approach we name it as a ModSim approach. So which is integrated well in hand with the designer and the simulation analyst. So these kind of approaches will add definitely add more value to your products. So then you can save a lot of time in the design cycle itself. So instead of whenever a design changes is being made from the designer, so you will be importing your model back into your FEA software. So you will be spending more time in pre-processing, repeating the pre-processing stages and the functionalities. So these kind of modism approach, like you can just easily adapt to the quick changes which is made by the designer. So thereby producing your FEA results in a very ahead manner than in the traditional approach. So these kind of approaches is being supported within this particular SIMULIA platform. So these kind of technologies will help you in adding more value to your products rather than sticking to your traditional approach. So you will be saving a lot of energy and time, and then you can have a effective communication within your colleagues as well. So when it comes to the electromagnetic part, so you can just see we have a solution called Opera. So this Opera, it is basically with this Opera, you can on top of this kind of structural and fluid dynamics workflows, you can add the electromagnetic performance workflow as well for the same component. So you can see here, for your motors, like you can add your electromagnetic simulation and then calculate your different KPIs. So either it can be a torque or flux or inductance. So all these kind of different EM parameters can be evaluated then on top of the structural and these kind of fluid dynamic approaches. So your performance of your particular products is being tested in all the domains, not only in the structural and the CFD. So with this help of this kind of Opera, you can just you can evaluate the performance of your product in terms of electromagnetics. So you can see this particular workflow. So in addition to these kind of structural inputs, you can add these kind of workflows. So let us see what is Opera, how it is useful for these kind of low frequency applications wherein you design either your magnets or your particular motors as well. So how these kind of simulations are performed in Opera. So what are all the kind of the solvers that this Opera has, all these kind of the technicalities you can just see in the further slides. So as you can see here, the SIMULIA Opera, it is a particularly a finite element analysis package. So which is the model which is created to simulate either in the 2D or 3D with the electromagnetic simulation capabilities. So either it can be a multiphysics, either it can be an electromagnetics or a space charge or including the stress and thermal. So all these kind of multiphysics can be included within this particular SIMULIA Opera solver. So it is majorly developed for building the accuracy and the robustness. So and then the speed and the ease of use. So when it comes to electromagnetics, you can see the major capabilities of this particular Opera. You can see in terms of electromagnetics, it has the capability to solve both the low frequency and the high frequency electromagnetic simulations. So also with the static and the electromechanical. Other than these kind of low and high frequencies, it also can handle these kind of certain structural thermal solver capabilities. So also the space charge where you can simulate all these kind of space particles. So along with these kind of things, you also have this quench solver, all these machine environments. So all these kind of different other applications are also being handled with this Emacs solution. Yeah, so when it comes to the Opera's pre-processing, as in other tools, you can just start creating your own models. You can create within this Opera environment, or else you can just do a mix match of these things. So either you can create a single part in this Opera, and then you can import the other part from a neutral CAD file format from an external software. Or these kind of when it comes to in terms of geometric preparations, these kind of mix and match scenarios has been possible. So and all these kind of CAD data has been accepted by the software. When it comes to meshing, you can see different meshing algorithms has been supported by this software. So you can just mesh different parts in the different algorithm. Either you can mesh stator with the hex mesh or the pentamesh. Also, you can mesh your stators and rotors with the tetrahedral mesh. So, and the major advantage of this particular things is the meshing is being done automatically. So, and also whenever you change your designs, it has been reflected automatically. So all these kind of automatic machines make your pre-processing more quicker, and then you can evaluate your more simulation models within a shorter span of time. And also, you can see the different material capabilities. This Opera supports these kind of fully nonlinear functionality materials. This kind of hysteresis inputs can be, the metal model can be built, and then you can analyze the hysteresis laws as well in the output. So all these kind of demagnetization superconducting effects can be captured in the material modeling level as well. So these are the various functionalities when it comes to the pre-processing within the Opera. Yeah, like whenever you gather certain inputs, like for example, let us consider these kind of synchronous motors. So with this Opera, you can just start building your particular stators in the rotors. So you can see like these are the various inputs that an analyst can provide to the software. So either in terms of whenever you are designing your stators, you can provide how much slot should be there in this particular rotor or the stator, and then how much pole should be there. So you can just give various inputs to design your stators. And when it comes to the rotor, when you see in the right hand side, so there are other different configurations when it comes to synchronous motors. So you can set up like how your void should be there, what is the shape of your rotor void. So either it should be a circular or different shape. So all these kind of input parameters are being given to the software by the users. So based on which you can just control your the void shapes, the void gaps, or the void thicknesses. So also you can see here, so how this kind of void circles has been designed, how these kind of various thickness of these voids has been given as an input. So accordingly, you can create your own status and rotors by providing multiple inputs. So these kind of void dimensions plays a major role in these kind of synchronous motors. So all these kind of different algorithms and the inputs are being considered by this software when it comes to designing the motor. So in addition to these kind of inputting the stator and rotor details, like you can also give input in terms of the material properties, in terms of the winding layout, how your winding should be there, so how much layers should be there, how much turns per phase it should be there. So all these kind of winding layouts can be provided as an input to this software along with this kind of operating voltage. So how in which voltage your particular motor is running. So and also you can control with your speed versus either your frequency. You can input your frequency along with in which mode it has been operating, either it is in AC or DC, along with the converter circuits. So all these kind of multiple inputs has been accepted by this software. You can also define, in addition to these things, you can define this inertia, so the friction level, and along with the load parameters. So all these inputs, based on these inputs, you can just extract. You can use these different solvers which is available within this electromagnetic solvers. We'll be seeing in short like what are the different types of solvers which is available to solve these kind of different uh, problems which is related to different EV motors. So there are different options available in terms of motor. Either it can be an induction motor or the synchronous motor. You can just priorly choose the which type of motor you are going to design. Then you can provide various inputs. So in terms of the void, in terms of the slots, so how the slot should be there. So what are all the operating voltages and the frequencies of your motor. All these kind of things you can just input, and then you can use these kind of different solvers, electromagnetic solvers, which is available. So Opera, which is the best known solver for this kind of low frequency applications, wherein you design your magnets, your motor applications, motor machines. So all these kind of low frequency electromagnet is being completely handled by this Opera. So it is a very robust, powerful solver. So you can extract all these kind of solvers in your either it can be a low frequency application or high frequency application. So both can be handled by the CMAX solutions. In addition to these kind of low frequency and high frequency, so you can see here what are the additional capabilities that this solver can provide. So it can handle a certain level of thermal and the stress level of solvers are there. So wherein you can predict your multiphysics a combination of the thermal and the stress. So you can also use your Quinn solver to predict this kind of the transient thermal behavior of your particular magnets. So thereby estimating your superconducting magnets, how it is performing and in this kind of transient thermal conditions. So also there is a solver for charged particles. So wherein you can just simulate the trajectory of the particles, how it is behaving, all these kind of things. So these are the different set of solvers which is available within this particular EMAX solution. And when it comes to this post processing, like you can see, like there are various options in terms of different plots you can obtain your post processing as well. So you can see, like you can extract your outputs in the 2D plots. So either in form of these kind of graphs, contours. So various level of flux lines and the flux vectors can be visualized as in terms of output for your different motor configurations. So and also when it comes to these kind of further results, like you can see, like there are different integrals which can be extracted, or you can extract outputs based upon different elements. Either you can extract outputs based upon the surfaces, or based upon a line, or based upon a volume. So all these kind of multiple output post processing capabilities will make to evaluate your products more robust in more robust manner. So you can see, like various outputs taken in this particular field, like either you can take a torque versus angle output, or torque versus slip frequency or as an output. You can see the various graphs which is taken for this particular motor, and also you can estimate your iron losses and the copper losses along with the particular you can just define your particular slip frequency, and then you can obtain the output with respect to torque versus frequency, torque versus slip, then the torque versus angle as well. So yeah, here you can see, like so how the data has been generated, the post process with the static torque versus angle. So you can just evaluate in different forms, either in terms of contour or these kind of 2D plots. So here you can see, like this flux density. So whenever your rotor is dynamically rotating, so the air gap maintains this flux density. So how this radial flux density has been changing according to the rotor angle. So and also they have evaluated their products for different operating currents. You can see the graph in the bottom, like so how the torque versus angle has been varying with the different operating currents. So in terms of torque, and then in terms of the angle, so you can just input different currents, and then evaluate your products, so which is the best operating situation for your particular design. And also when it comes to the output, like as I mentioned, like you can see this particular air gap between the stator and the rotor. So when it is dynamically rotating, these kind of flux variations, you can easily estimate, like so what is the you can see in this graph, like the variation in this flux density. So along with this particular dynamic situations can also be evaluated in addition to this, like you can also take these kind of EM forces, because also the centrifugal loading of your particular components will be added on top of these kind of EM stresses. So with the help of, in addition to these kind of, on top of this centrifugal loading, how your particular products has been performance has been evaluated. So all these kind of different peak torques, maximum displacements, and along with the maximum stresses, so all these parameters can be evaluated. So along with the torque versus position can be plotted like in this 2D graph. So in addition to these kind of parameters, like you can see, like these kind of inductance parameters has been monitored. So either in terms of, you can take both the axis, either in the D or Q axis inductance, it can be completely monitored. So how your Q axis has been varying in terms of whenever you provide the barriers, you can estimate, like so whenever you set in the input, like you'll be defining a voids, number of voids. So how much is the thickness of the each voids? So based on all these input parameters, you can estimate these kind of inductance parameters with respect to Q-axis. So also you can just see this kind of cross coupling inductance versus current, and also this DQ inductance versus current. So you can just estimate these kind of various output plots with the help of these kind of Emacs solutions. On top of this particular outputs, like you can just add a more multiphysics into this. You can include these kind of thermal and then the structural within this particular solver as well. So it has a capability of handling this kind of multiphysics within the single solution. So these are the various outputs which can be plotted when it comes to these kind of reluctance motors. So you can just provide a lot of different inputs in terms of designing right from the start of the designing stage, and then you can evaluate the performance of your products. So when it comes to global references, like you can see like a lot of big names added in this customer references, like so they are the global team who has been getting benefited by these kind of solutions, this SIMULIA solutions. So right from so Jaguar, Volkswagen, Honda. So you can see like different organizations which has been performing these kind of multiphysics simulations with the help of SIMULIA software. So these are all the global references. So you can just have an deep dive of these kind of so and all using this kind of solutions. So right from Tesla, Land Rover, so all these kind of major big players are using these kind of solutions to optimize their products performance. So like from you can just right from not only you can just evaluate your products in terms of structural, like as we saw, like you can also include your electromagnetic workflow into your particular product design. So then you can completely evaluate your products in terms of all the multiphysics. So then these are all the additional values with the help of SIMULIA. Just you can reduce your development time, as we were seeing like so we were seeing a modular approach, like how you can integrate both within your CAD environment along with your FE environment. So thereby you can reduce your production design and development time. So along with it brings your high accuracy in terms of solution. So and also you can perform these kind of multidiscipline optimizations. Either it can be in electromagnetics or structural. You can perform these kind of multidisciplinary solutions. And also it is also connected and collaborative environment. So thereby you can just work efficiently with your cross functionality teams. So these are all the major advantages of using these kind of softwares, and also it provides you like it provides a unified environment, like wherein you can uh, maintain all your legacy data and all your in data simulation data as well in a single environment. So you need not switch over to an additional third-party softwares to switch in between these kind of multiphysics. So within the single environment, you can do all these kind of various aspects as well. So that is the one of the major advantage of these kind of solutions. Uh, so yeah, like that's about this presentation. So if you have any of the queries like regarding this particular slides, so you can just either you can raise your hands or you can post it in this questionnaire box.
Yeah, thanks, Sanjeev, for the presentation. We do have a couple of questions. So the first question is, what type of analysis can be done in Opera?
Yeah, basically, like as we saw, it has different kind of solvers. It is more robust when it comes of in terms of motor design. So it is the most robust solver. So you can just perform all these kind of low frequency analysis, low frequency application analysis. Either it can be a magnet or it can be a motor design. So since we are considering in the EV sector, the motor is a critical component. So this kind of solutions offer more wide range of options in terms of designing and optimizing their products. So all these kind of low frequency applications can be addressed through these kind of solutions.
Thanks, Sanjeev. Another question: what are the materials which can be analyzed in the Opera software?
Yeah, materials. Yeah, as we were seeing, like you can just add your hysteresis data. You can add your demagnetization data. So, and also you can just add your particular. You can calibrate your material, and then you can just define all these kind of additional parameters to obtain a most accurate and robust result when in terms of Emacs solutions.
I
Yes,
think
sir.
we can have one final question. Is it
Yeah.
applicable for 2D or 3D analysis or for both?
Yeah, basically Opera is designed for both these kind of 2D and 3D analysis as well. It supports both 2D and 3D. You can perform, you can, as an initial part of analysis stage, you can just perform an 2D analysis and then you can evaluate an initial phase of results. So based on which you can upgrade your products design parameters and then you can push into the same analysis into a 3D. So both are supported by this particular Opera.
Okay. I think that's all the questions we have. Maybe you can move to the next slide.
Yeah, like in
Yeah.
case of like
One,
yeah, you can
uh,
go away.
yeah. So I would like to thank you, Sanjeev, for delivering a very informative webinar. I'm pretty confident that it was very helpful to our audience as well. I would also like to thank the audience for taking their time out and joining us for this session. So if you have any further queries related to the subject matter or any other simulation requirements, you can always connect with us. Our credentials and details are displayed on the screen right now. You can reach out to us anytime and we'll be happy to address your queries. Furthermore, your feedback would be invaluable for us and it will help us in improving our engagements in the future. In this regard, I would request the audience to please fill out the feedback form, which shall pop up once the webinar is closed. Please do keep an eye out for our upcoming webinars and seminars. You can follow us on our social media for the same. Thank you once again for joining us today. See you at the next session.
Yeah, thank you, Abhay, and thank you all the attendees. Thank you.
Thank you, Sanjeev.
Thank you.